Hello guys, how's it going? How are you? Good afternoon. Now we're gonna continue with our, I think, fourth or fifth stream of the day. I already forgot. We have been studying the whole day about this. And now I'm gonna check my audio first. I already. And then we're going to go and check the. We're gonna continue with the third chapter of building applications with pinecone. So let's continue, guys. Multi-tenancy and namespaces.
Batching is just one way of optimizing your query performance and data infrastructure. In this video, we'll explore another. Multi-tenancy is a software architecture where a system can serve multiple groups of users, more generally referred to as tenants, in isolation. In pinecone, this typically refers to storing distinct datasets in separate namespaces while being served by a single index. This architecture not only allows us to separate data from different groups of users to ensure security and privacy, but can also reduce query latency, as queries can be directed to specific namespaces, reducing the search space. As we've discussed, namespaces can be used to separate vectors within a single index, which enables targeted queries by minimizing the number of scanned records. While this reduces the need for extra indexes, resource sharing and data deletion can become a challenge. There are also other strategies available, which may suit certain use cases. With metadata filtering, we've seen that we can attach metadata to records and use queries to search over records with specific metadata. This enables querying across tenants, but may result in shared resources and cost tracking challenges. Lastly, we could create separate indexes for each segment, providing dedicated resources to each tenant. This model offers maximum isolation, but it requires additional effort and cost to maintain multiple indexes. We'll focus on option 1, utilizing namespaces. Namespaces are created implicitly during upsertion if they don't already exist. For example, if we upsert vector set 1 into namespace 1 using the namespace argument, namespace 1 will be automatically created if it doesn't already exist. We can continue to create more namespaces by specifying new namespace names when upserting the different set more one using the namespace example. If we upsert vector set 1 into namespace 1 using the namespace argument, namespace 1 will be automatically created if it doesn't already exist. We can continue to create more namespaces by specifying new namespace names when upserting the different sets of vectors. We can inspect our namespaces with the describe index stats method we've used previously. In the output, we can see that the vectors have been successfully upserted and distributed into the two new namespaces.
Okay.
Now that we've created separate namespaces, it's time to query them. This only requires one additional argument to indicate the namespace name that should be queried. Querying isn't the only operation that can be done on the namespace level. In fact, all of the index operations we've looked at can be directed to specific namespaces. For instance, we can delete vector IDs from specific namespaces. This is particularly useful, as IDs only need to be unique within a namespace. So there may be other records in different namespaces with the same ID, and we wouldn't want to delete those accidentally. Now it's your turn.
So now we are gonna stop sharing our data camp, and we are gonna go to our Visual Studio. So in this case, I'm gonna clear here, and then we're gonna do the number 17, and the exercise gonna call namespaces. And in here we're gonna it's asking us to do a few things. One of the things is initialize pinecone with your IPA key. Okay, we're just sharing Visual Studio, so I can do this here. Then upsert, so I should do pc.upsert, and then into namespace, and this should be namespace 1. And then same here. I'm just running it first into this data camp, so you will not see it at the moment. And this here, namespace 2. The descriptive indexes should be from here. I'm gonna run this here. I should get first the data camp index. Alright, so it should be index.absurd, index.absurd. So technically in here, I'm gonna insert two vector data sets. I'm gonna grab this and I'm gonna get the stats. And I'm gonna submit here in this. Okay, that's good. And to cloud, I'm gonna ask that for this file, please create two new vectors set missing so we can run the file. All right, so now querying namespaces. So we are gonna do exactly the same. Data count, so it's gonna be index.query, and this query is gonna be vector okay. So this is gonna, so basically if I run this number 17 here, now I should see there that there's three namespaces, one that it wasn't defined, and then the namespace 1 and namespace 2. Okay, I'm gonna ask when I insert a vector without defining the namespace, that means put to the general namespace. Okay, then here I'm going to do 18 query with namespaces, and here I'm gonna do basically this query, this is gonna query this vector. Now complete this file, so I can the file. And just in case I'm gonna hear the explanation, yes, so you observe with the specific vectors getting to the default namespace with an empty stream, so that's why here I got three namespaces. Alright, now when I query with the namespace 1, that means that I'm gonna first create a vector there. I'm gonna run this into, okay, this is wrong because it was missing the query. The top K I also need to get here, and this is gonna be the top 3 results. Yes. And it was missing this here, top K. Okay, so now it's good. Now with namespace top K. That's good. Let's continue. Okay, guys, and now we're gonna go with the semantic search with pinecone, which is a lecture. So now we're gonna come back to our Firefox with DataCamp. Now we're gonna see this and we're gonna listen.
Welcome back. In this video, we'll learn how to build a semantic search engine using pinecone. Semantic search engines use embeddings to return the most semantically similar results to a user input. This involves embedding and ingesting a series of documents to search through into a pinecone index, embedding a user query, and using the user query vector to query the index and return results. We've seen how to ingest vectors and query indexes, so the final piece we need is to be able to embed the document and user query to create the vectors. For this, we'll use an OpenAI embedding model. We'll initialize pinecone and OpenAI clients, and create a new serverless index specifically for our semantic search application. We give this index a dimensionality of 1536, which is the dimensionality of the vectors outputted by the OpenAI model we'll be using. If another embedding model is used, be sure to check the output dimensions and use that here. Finally, we connect to the index. With our pinecone index ready, let's prepare our documents for indexing. We'll be embedding and ingesting the squad dataset, comprising of Wikipedia articles that we can semantically search through. We start by importing pandas for reading the data with readcsv, numpy for a couple of data manipulation functions, and uuid, which we'll use to generate unique record IDs before upserting. The dataset includes columns for article ID, text, and title. To begin ingesting documents into our pinecone index, we set a batch limit to process 100 documents per request for efficiency. We'll iterate through the documents in batches using numpy's array split function and batch limit to create batches from the data frame. With each batch, we'll extract the metadata into a dictionary using a list comprehension. This creates a metadata dictionary for each row in the batch, assigning the row values to dictionary keys. We also extract the article text to embed and create unique IDs for each row using the uuid4 function. Next, we create a request to OpenAI's API to embed these texts, extracting the raw embeddings from the response.
Okay, so I create the embeddings with OpenAI. Okay.
Finally, we zip together the IDs, vectors, and metadata.
So I got all of them, which is the IDs, embed squad data set. Okay.
And upsert them to a new namespace called squad dataset. As before, we can verify the upsertion with describe index stats. Let's now perform semantic search with pinecone. Consider the following query. To initiate semantic search, we encode this query using the same embedding model again. It's crucial to align the embedding model used for the query and the documents to ensure consistency in dimensions and processing methodology. Once the query is encoded, we query the namespace with it. We added the include metadata's argument here, so we can access the article text, which is stored in the metadata for the returned records. We can loop through the returned records and extract the similarity scores and texts. Not bad. Time for the returned records.
So they embed the query.
We can loop through the returned records and extract the similarity scores and texts. Not bad. Time to build your own semantic search engine.
Oh, there's a lot of new info. All right, let's go here. So now let's stop sharing the data camp. Now let's go to Visual Studio. Now here we're gonna do, this is gonna be the number. 19 is create config pinecone index, and in here I'm gonna first put the pinecone key in data camp, then the name is gonna be pinecone data camp, and the dimension is gonna be this. Because of the fact that here we already have this import from here, we don't need this, so we also don't need this one. Then from here connect to the index, so it should be and then I should print this. Okay, I'm gonna put this in here. I'm gonna run the Python 19. And here I see that shit. No. So here's just that I was configuring the wrong one. Okay, in the 19 here, I am creating this pinecone data camp and then I'm connecting to it. So now I'm gonna run this correctly. I'm gonna close all of the other ones just to not confuse myself. And now we should import the serverless spec, which is going to come from here, from pinecone 2. Yeah, and now we are gonna do this the 19. And I already see, yeah, because I already created that in data account. So basically, if I show you my databases, this pinecone data camp, 1 second, is gonna be in here. You see there, pinecone data camp. So coming back to Visual Studio, now that is correct, and then we're gonna go to the next exercise. In the next exercise, what we are gonna do is upserting vectors for semantic search. So in that case, so we're going to do this. It's going to 20. Upserting vectors, semantic search, and here is going to be patch limit. And here I'm going to do this. And in here, what I'm going to do, first I'm gonna save, then so here I'm splitting the data frame. The data frame was loaded, so basically extract the ID, the row text, and the title, create the IDs, and then 1 second, because I'm doing it on data camp. Here I have this, then the input here is going to be the zip of the IDs, the vectors, and no, the input, the texts, and the metadatas. And here is going to be namespace is called squad data set. And in here, and here is going to be the texts. I need to do the client, I guess, in code. And then absurd, and it will be just absurd. Sorry, now I'm gonna run this, but I'm gonna put the API key here. Run. OpenAI has not attributed in code. I forgot the client embeddings create. This is just to embed the input. Okay, so if I run this, it ran good. So in this apps, okay, and now I have it running, and now it's good. And the thing is that here we need to put this file, which is the data set, the squad data set, and we're gonna copy this from here into here, and I'm gonna say, so it's already there, and I'm gonna say to Cloud, for this file, please complete, so we read the data frame from the squad data CSV in the same folder. Because first we need to read this squad data set from there, and then we need to create a data frame. So I understand everything here. The only issue is I create embedding, so this creates the X embedding for X and respond. So it's creating the embeds as a array. So you have multiple arrays, multiple IDs, and multiple metadatas. And I just need to wait, why it didn't copy it all good? That is here. Index that absurd. That's all. I don't know why I have this, all of this here inside. This is wrong. Wait, I'm gonna do this. I'm gonna save and I'm gonna do yes. Okay, just with this is okay. I'm gonna ask here, what does the zip function does in Python? What does zip function does? Aha. So it's creating a uh, okay, here I think we need to copy this OpenAI client here, and I'm gonna say no. We can use the OpenAI client. OpenAI client like in the other files. So okay, so in the case that I made zip IDs, embeds, and so what if I do this? These are just 3 arrays. How does No, 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 no. No, I think no. I think you can do this. And let's wait. Because here I need to do. I may have this code. I mean in this code. Aha. So instead of making an iteration, so pinecone accepts so each table because one record in the so basically when I do this zip, like this absurd accepts like a list of tuples, and then in this case are triples that is gonna receive the ID, the vectors, and the metadata. Okay. So here I'm seeing the changes. Here's one change because now it's gonna do another one, I think. Now it's gonna. Okay, it has the data frame here. So that's pretty much it. So now we see that into the if we run this, which is the Python 20, and if we go into this namespace, which is squad dataset, we'll see that we just added that there. Okay, that's good. And I have one error here. Okay, client embedding script. Oh no, I didn't have an error. What? I'm passing the error to know what is going on there. Aha, so that's a new NumPy version. Okay. Okay, so let's run this. Now we have this error. Uh-huh. All right, so it's unnecessary. Okay. So now we need to do this 21 querying vectors to search. And in here, well, first I'm gonna do it in data camp. You cannot see, I'm sorry. Then the query should be the input should be the query, and this should be index.query. No, this should be client dot retrieve docs should be index dot query, and in index dot query I need to do I need to pass the vector in which my case should be the query embed, and I need the top case should be 5 because I should get 5 similar tip dot matches, and it's gonna do like this. Okay, so if I run this, I need to, just in case, I'm gonna do this here. And I think I have everything there. So I get the query, I embed the query, I get the query response, I get the embedding I pass it as a vector, I query, I retrieve the docs. In my case, the top case should be, I put 1, but should be 5. And then I print the matches. So if I run the 21, why is not printing nothing? Give me 1 second. I didn't specify the namespace, so that's why it wasn't returning nothing. So then the namespace should be, so that's why it's not getting nothing from there. All right, and that just makes sense. So if I put the namespace here, it's really important because now I clearly understand why it wasn't returning nothing from there. Yeah, I see it there. It's giving me the ID and the score. It was from pinecone data camp and the squad data set. And how was the squad data set I was looking? ID text. So it's giving me the IDs. Okay, there is something really weird. Mm, because but I generated the IDs as a SUID. Okay, so I was thinking there's a direct match, but here I'm generating the UID. So that's why they are different. Okay. Rack chatbot with Pinecone and OpenAI. Okay. Okay. I think we're gonna leave this for tomorrow. We need to take a break. It's a lot of information to process and to leave to rest in the mind. So okay, so I'm gonna do this. I'm going to yeah, guys, let's take a small break and we come back with this tomorrow morning.